reflection of light. So what is meant by reflection? So what is that phenomenon? How does it can be defined? Okay, let us take a football or a ball. So then take a ball and hit it against a wall. Otherwise, just hit it in a ground. Then it will be in its own path. Unless until it is stopped by any other, it will be in its path. The same ball and it is in its way. Yes, so no one is stopping it and it will be in its motion. So whenever there is an obstacle comes in front of it or in its path, then it will be stopped. It will be stopped and it will be bounced back somewhat. Yes, whenever you take a ball and you hit against a wall. Yes, against a wall, then it goes to the wall and in its way, if it is not obstructed by any other, it will be in its way. So whenever it hits the wall, then it bounces back. Okay, this process is called as reflection of ball. Yes, light, right? We can say that reflection of ball. That means it is going there. Yes, it is hitting something and it is bouncing back. So that is reflection. The phenomenon involving in that is called as reflection. Yes, let us see the same thing in case of light. Yes, let us take this is the plane of reflection and let us draw a normal. Okay, I'll explain you what are these terms later. So let's take a normal. Yes, so this is the point where we are passing a light, where we are hitting a light ray. Okay, so from here we are passing a light ray onto this plane. Yes, so it hits this mirror or this surface at this point, then it bounces back. It bounces back into the same plane, into the same media. So this process of bouncing back of light ray when it hits an opaque object is called a reflection. Once again, the phenomenon or process, or phenomenon of bouncing back of a light ray when it hits an opaque object is called as a reflection of light. Reflection of light. So then what are the terms involved in this reflection of light? Okay, plane of reflection. So here what is plane of reflection? The plane where the reflection process takes place. The plane where the reflection process takes place is called as plane of reflection. In this case it is plane mirror. Okay, next incident ray. Incident ray. So what is the second one? Incident ray. So what is incident ray? The ray of light which is falling on the mirror or plane of reflection, that is called as an incident ray. The ray which is falling on the plane is called as an incident ray. Yes, so incident ray. And next one, reflected ray. Reflected ray. So this is called reflected ray. Reflected ray. So the ray which is bouncing back, from the plane of reflection, or the ray which is bouncing back from the plane, yes, is called as a reflected ray. Yes, and next normal. It is called a normal. So then what is the definition for normal? Yes, an imaginary line which is drawn perpendicularly to the plane of reflection is called as a normal. Yes, so it is an imaginary line. It actually doesn't exist there. Yes, so we can pass incident ray and it can be reflected back. We can see these two rays. We can see the incident ray as well as a reflected ray, but we cannot see the normal there. Yes, so that is just an imaginary line which is drawn perpendicularly to the plane of reflection. So that is called the normal. So this is in case of plane surfaces. This is the process of reflection in case of plane surfaces. So there is an angle between incident ray and normal which is called as angle of incidence I. Angle of incidence I. Angle of incidence which is denoted by I. And next there is an angle between reflected ray and normal. Reflected ray and normal which is called as angle of reflection, denoted by R. So the angle of incidence and angle of reflection, both we are taking between the normal and incident ray, normal and reflected ray. Okay, don't confuse here, don't be confused here. You should not take the angles between this plane and this rays. Okay, never be taken like that. So it should be taken between normal and incident ray, normal and reflected ray. So the angle between normal and incident ray is called as angle of incidence I, and the angle between normal and reflected ray is called as angle of reflection R. Angle of reflection R. Yes. So next the laws of reflection. Next one, there are two laws of reflection. The first law of reflection, let us discuss about first law of reflection. So here in incident ray, it is hitting the plane and it is reflecting back. Yes, there is an angle formed between incident ray and normal. Okay, this is called angle of incidence. And next it is reflected back, and there is an angle between this normal and reflected ray, that is angle of reflection R. In any situation, this angle of incidence and angle of reflection should be equal. Okay, so this angle of incident and angle of reflection should be equal. So it shouldn't be in this manner, right? So the angle of incidence and angle of reflection must be equal. That is the first law of reflection, that is I equals to R. I equals to R. Angle of incidence equal to angle of reflection in any type of reflection process. Okay, whatever the surface you take, in all the surfaces, in all types of reflection process, that angle of incidence must be equal to angle of reflection. It will be valid for all the reflection processes. Okay, and next second law of reflection. Second law of reflection. Here let us take this point of incidence. Here in the second law, this is the important thing, is the point of incidence. Point of incidence. So at the point of incidence, incident ray, reflected ray and normal. Incident ray, reflected ray and normal, these three lie in the same plane. These three lie in the same plane. So far we have discussed about the reflection of light on plane surfaces. The reflection of light on plane surfaces, that is it is a plane of reflection. The terms involved in reflection of light on plane surfaces is, the reflection process is the plane of reflection, the plane where the reflection process takes place, and incident ray, the ray which is falling onto the plane of reflection. Next, the reflected ray, the ray which is bouncing back, which is the ray which is bounced back from the plane of reflection. And next, normal, an imaginary line drawn perpendicularly to the plane of reflection. Next, angle of incidence, the angle between normal and incident ray. Angle of reflection, the angle between normal and reflected ray. Then last, first law, angle of incidence equal to angle of reflection, and second law, at the point of incidence, incident ray, reflected ray and normal, three lie in the same plane. Next, curved surfaces or spherical mirrors. So far we have discussed about reflection process on plane surfaces. Actually our topic is reflection of light on curved surfaces. Reflection of light at curved surfaces. Okay, let us take what are curved surfaces and how the curved surfaces are prepared. Okay, let us take a sphere. Let us take a sphere just like a football. Football is also called as a sphere because it has some boundary and it has hollow space inside it. Yes. So if the glass is a sphere made up of glass, a sphere made up of glass. So it is totally glass and it is totally hollow space inside the glass. Yes. So then let us take a small portion of the sphere. Let us take a small portion of the sphere. Okay, we are cutting this small portion from the sphere. Okay, so this is taken, this part is taken from the sphere. Okay, just I am drawing that, the same one. Okay, this is magnified. So this is the small part I have taken from the sphere. Yes, and it is the curved surface. It is the curved surface and it is glass. It is totally glass, then it must be made into mirror, right? It must be made into mirror. So we have to coat something, that is the silver, it should be silvered. So whatever the plain mirror or spherical mirror, so that mirror will be prepared by silvering it, because why we should use only silver? Silver is a perfect emitter, a perfect reflector, it doesn't absorb the light. So that is why we should coat some silver on it. Yes, it is coated with silver, and then here the silver is coated. So just let us take this part is totally silver. Okay, this part is totally silver, and the silver coating is there, and it will be oxidized, right? The silver will be oxidized and it will be corroded. It will be corroded if it is not covered with any other paint. Yes. So then after that, above that, a paint will be coated. That is red lead oxide. Red lead oxide will be coated on it. Yes. First, it is a glass which is taken from a spherical material. Yes. So this is a small part I have taken. It is totally only glass, and on this, what I have done, a silver coating has been taken. Yes. Then after that, just above that silver coating, there is paste, or there is a painting of red lead oxide to prevent the silver from corrosion, right? So then now it behaves as a mirror. Now this is the non-reflecting surface. This is the non-reflecting surface because we have painted it or coated it. This side it is coated, and it is totally smooth surface. It is totally smooth surface. This part is totally smooth surface, which is the reflecting surface. Okay, so this is non-reflecting surface, this is reflecting surface. In case of this plane mirror also, I have already said that this is reflecting surface and this is non-reflecting surface. Okay, next we have taken this part and we have put it on this side. Okay, let's do another thing. Let us take this part. Yes, I have taken this part and it's magnified. Okay, this is the part I have taken. Let us coat on this side. Okay, so are you observing this? So I'm coating on this side now. I have coated on this side now, this side of the part. Okay, and next now I'm coating on this side. Okay, on the inner side. Here it is coated on outer side, and here it is coating. I'm going to coat on inner side. So let us coat it. That is the silver. There's a silver coating, and next on this red lead oxide coating. Okay, both. So both I have done. So it is the coated surface or silvered surface, and it is non-silvered surface. So this acts as a non-reflecting surface, non-reflecting, and it is a reflecting surface. Okay, this is the reflecting surface, this is non-reflecting surface. And let us see the difference between these two curved mirrors. Okay, so I have taken two curved surfaces from the sphere. I have taken two curved surfaces from the sphere, and one is coated on outer side and one is coated on inner side. Okay, so here the reflecting surface is curved inward in this situation. Okay, in this scenario, the reflecting surface is curved inward. Okay, in this scenario, the reflecting surface is curved outward. Okay, let us take this is a plastic strip. Okay, so let us take this as a plane mirror. Let us assume that this is a plane mirror. Okay, so it is a plane mirror just like this. Plane mirror, it is reflecting surface. It is a non-reflecting surface. The black one is non-reflecting surface. Let us assume, and it is a reflecting surface. This is a plane mirror. Plane mirror, there is no problem that we are using in our homes. Okay, and this part just we have bent it like this. Okay, so that means this outer surface is coated, and this inner surface is behaving as a reflecting surface. Means the reflecting surface is curved inward. ఇక్కడ ఉన్న reflecting surface అనేది inward కి కర్వ్ అయింది. ఎస్ అంటే నా సైడ్కి నా వైపుకి బెండ్ అయింది. ఓకే, సో దిస్ బికమ్స్ ద రిఫ్లెక్టింగ్ ద cave like surface becoming as a reflecting surface. So this one is called as, this type of mirror is called as concave mirror. Concave mirror. Concave mirror. So it has a cavey surface as reflecting surface. Cavey surface. Cave, you know that cave అంటే ఏంటి? గుహలాగా ఉండేది, లోపలికి వెళ్తే గుహలాగా ఉండేది అని అర్థం. ఓకే, సో ఇక్కడ ఏంటి రిఫ్లెక్టివ్ సర్ఫేస్ ఎలా ఉంది? కేవ్ లాగా ఉంది, ఒక గుహలాగా ఉంది. సో దట్ ఈస్ concave surface. Next, let us take another one. Okay, so here the reflecting surface is curved outward. Yes, reflecting surface is curved outward or bent outward. Okay, నా వైపు నుంచి అవతల సైడ్ కి బెండ్ అయింది. ఓకే, రిఫ్లెక్టింగ్ సర్ఫేస్ అనేది అవుట్వర్డ్, నా వైపు నుంచి అవుట్ సైడ్ కి బెండ్ అయింది. సో this becomes the reflecting, this is the reflecting surface and it is not reflecting surface, right? So this is called as convex mirror. Convex mirror. So have you got it? Now the spherical mirrors are those which are obtained from a sphere. Spherical mirrors are those which are obtained from a hollow sphere, right? And from that we can prepare the two types of spherical mirrors. What are the two types of spherical mirrors? One is concave mirror, one is convex mirror. And what is concave mirror now? If the reflecting surface is curved inward, that is called concave mirror. If the reflecting surface is curved outward, that is called convex mirror. Okay.